Dear students, I once again extend my warm welcome to the GATE coaching class session. In today's class, we will be discussing about the important problems related to network theorems, right? Before going to the session, I hope you were able to understand the basic concepts related to mesh and node analysis that we discussed in our previous class. Okay. You should understand one thing, whether you implement a mesh or nodal analysis for a certain problem, you should consider two things always in mind. The first thing is that it should be less complex in applying the steps, and it should not consume more time. Okay. So if you consider these two steps carefully, you can obviously work out the more problems, and you can secure good GATE score, right? Okay. In today's class, let us focus our attention particularly on network theorems. When we start with the network theorems, you know that we have following set of important theorems such as superposition, Thevenin, Norton, maximum power transfer, reciprocity, and Tilligans, and sometimes even Millman theorem. But to focus our attention on GATE preparation, most questions will be based on superposition, Thevenin, and Norton, and one or twice even maximum power transfer theorem has come. Okay, so it is always advisable to work as much as problems based on these four theorems. Okay, now let us focus our attention on Thevenin's theorem first, right? Okay. Now consider this question given. Find the Thevenin's equivalent circuit at terminal AB of the network. So you should always understand one thing. By implementing a Thevenin's theorem, a complex network is converted to a simple network with an open circuit voltage connected in series with an equivalent resistance. The open circuit voltage is known as Thevenin's resistance, and the series resistance is known as looking back resistance or Thevenin's resistance. Okay. So our primary goal or the primary aim of Thevenin's theorem is to convert a complex circuit into a simple circuit with an voltage source in series with equivalent resistance. Okay. So in other words, you are converting a complex network into an voltage source. That's all. Right. Now let us consider this problem shown here. You have a voltage of 10 volts and active current of 5 amps and another active current of 5 amps with another voltage of 5 volts. The goal of the problem is to determine the equivalent circuit across AB. That's Thevenin's equivalent circuit. Okay. Now you can notice that which approach is advisable. So generally, any student who has practiced much better will know that we can proceed with the nodal analysis. To make the steps still easier, you can convert the voltage source 10 volts in series with the 2 ohms into a current source. Okay, so this we call it as source transformation. A voltage in series with a resistor can be converted into an equivalent current source in parallel with the same resistor, where I is equal to V by R. Right? Okay. Now the first step is let us convert the voltage source into current source. Right? So what is the voltage source? 10. What is the resistor? 2. So 10 by 2 gives you 5. Right? So again, the goal of the problem is we need to determine the Thevenin's equivalent circuit across AB. Okay. So it means that if you find V of 2, that is a Thevenin's equivalent voltage or open circuit voltage, right? Now, you can understand easily from the circuit, the best method to apply is nodal analysis, right? So we have two nodes, V1 and V2. Now, first let us apply the nodal analysis at V1, that is Kirchhoff's current law. Okay, so you can notice that both the currents 5 amps are entering, 5 plus 5, 10. And you can notice that another 5 amps is leaving, minus 5. So 10 minus 5 is equal to V1 by 2 plus again another V1 by 2 plus V1 minus V2 by 1. Right, this is equation 1. Now consider the second node. In the second node, current entering is 5. So V2 minus V1 by 1, V2 minus 2 plus 5 divided by 2 equal to 5. Right. So you have these two voltage, two equations. You can convert the equations into matrix form. Right. So this becomes a 2 cross 2 matrix, and you can find del. Del is nothing but determinant. And please understand one thing, V of AB is nothing but V2, right? So V2 is the voltage across the open circuit network AB. So it will be sufficient if you find V2 only. Don't waste your time by finding V1, which is not necessary for this problem, right? So V2 is nothing but del 2 by del. Correct. So 10 by 2, 5 volts. So the open circuit voltage is 5. Now, the next step is to determine the Thevenin's equivalent resistance. Okay. So you have to open circuit the current source, and that is you have to deactivate both the current and the voltage source. Okay. So open circuit the current source and short circuit the voltage source. That is, you just draw a straight line with the 2 ohm, and you can remove the entire voltage sources. Okay. So kindly understand one thing, if you open circuit the current source, the current will be 0. If you short circuit the voltage source, the voltage will be 0. This is what meant by deactivating. Okay. It means that the active source does not have any power. So once I deactivate the voltage and the current source, the circuit will be simplified as shown. Okay, so the Thevenin's resistance is actually the looking back equivalent resistance. Okay, so you can notice that 2 ohms and 2 ohms are connected in parallel. So that will give you 1. 1 plus 1, 2. Again, 2 and 2 are parallel. So the Thevenin's equivalent resistance is 1 ohm. Right? So you can notice this completes the problem. The open circuit voltage is 5 volts and the Thevenin's resistance is 1 ohm. Right? So this is how we have converted a complex electric circuit into a simple voltage network in series with an equivalent resistance. Okay. So this is the idea or goal of a Thevenin's equivalent circuit, or to determine the Thevenin's equivalent network. Okay. Now let us proceed with some more problems. Okay. So you can notice the circuit, and the circuit shown below, the Thevenin's voltage. So take care, this is a gate examination question itself, and he is not asking equivalent circuit. So be careful. You have to just focus on what is the question that has been asked. Okay. So here for the network given in the figure below, the Thevenin's voltage is what? So V of AB, right? Now you can understand, just check which method is best, right? You have several methods, okay, mesh node or source transformation, whatever may be, but see that try to approach a method which is less time consuming, okay? Now let us proceed with the problem. Okay. So you can notice that here I'm going to convert the current source into voltage source. Okay. So what is the current source here? 6 amps and connected in parallel with 5 ohm resistor. Okay. So once I convert the current source to voltage source, it will have a voltage V is equal to I in R, that is minus 30 volts in series with the resistor. Okay. So from the circuit, you can understand easily this modified circuit has two loops, but at the same time, it has only one principal node. So the best method to approach is nodal analysis. So you can understand node 1 is the principal node. I'm going to apply Kirchhoff's current law at node 1. V1 by 10 plus V1 minus 16 by 10 plus V1 plus 30 divided by 15 equal to 0. Okay. So from this, you can find out V1 is equal to minus 1.5 volts. So you can notice that here the steps are very simple and you can easily work out the problem. And be careful, in the question, they have given four choice, minus 1.5, minus 0.5, plus 1.5, plus 1.5. Okay. So the correct choice for this problem is minus 1.5 volts, right? Again, be careful students, when converting the current source to voltage source, the sign notation is very important, right? The tail of the arrow always indicates minus and the head of the arrow always indicates plus. So based on that only, I have made the source transformation. Okay, so this completes the problem and V Thevenin is equal to minus 1.5 volts. I hope you understood the steps, which was very simple and easy to follow. Right? Okay. Now let us proceed with the next problem. Okay. So in the circuit shown below, the V Thevenin voltage is what? Okay. So Thevenin voltage is across the open circuit with a single resistor 4 ohms. Okay. And dear students, always understand the open circuit does not carry any current. Okay, so it is virtually dead only, right? So the Thevenin voltage is actually voltage across the 2 ohm resistor. Don't make any blunder by finding the current through 4 ohm. 4 ohm is open circuit. Okay, so your observation is very, very important. Okay, so the actually V Thevenin is nothing but voltage across 2 ohm resistor. Now let us proceed with the problem. Now I have current source of 1 amp in parallel with 1 ohm resistor and 2 amps in parallel with 2 ohm resistor. I am going to convert the current sources into voltage source. If I want to convert the current source into voltage source, V is equal to IR. Okay, and a resistor in series with voltage source. Okay, so you can notice that in previous case, V is equal to 1 into 1 volt. And here for the second network, 2 into 2, 4 volt, right? So take care about the sign notation. The arrow head indicates plus, the tail of the arrow indicates minus, right? So the circuit has been modified in a simple manner, and please understand you have only one loop. The other loop is an open circuit. Since it is an open circuit, the current does not flow. It is virtually or actually it is a null circuit. Okay. So let us apply Kirchhoff's voltage law for the first loop. Okay. For what purpose I want to find the current I? So I is equal to what? V by R first. What is V? Minus 2 plus, plus 2 minus. Okay. So 3 minus 4 divided by total resistance for the first loop is 5. So I is equal to minus 0.2 amps. Right. Now what is V Thevenin? V Thevenin, you have to consider this 4 volt and 2 ohm with respect to open circuit. Minus 2 plus 4 plus 2 minus minus 2 plus, again minus 2 plus, plus 2 minus. So 4 minus 0.4 is 3.6 volts. Okay. So kindly understand, I have applied Kirchhoff's voltage law with respect to V Thevenin. And the most important point, do not consider 4 ohm resistor. It is a null pitch circuit. Okay. So minus 2 plus 4 minus 2 plus 2 into I minus VThevenin. What is I? I is minus 0.2 amps. Right? Okay. So please, students, students always be cautious. Okay. When you refer an open circuit, the current is actually zero for an open circuit. Okay. And when you refer a short circuit, the voltage is actually zero for a short circuit. If you understand and if you proceed based on this, you can work out theorems very well. Right? Okay. Now let us further discuss some problems related to uh, Thevenin's theorem, which was asked during GATE examinations. Okay. Now see the circuit. The Thevenin's equivalent voltage V Thevenin for the network shown below is okay. So this rather looks very simple, right? Because it has only two sources, one active voltage source and one active current source, and it has certain resistors. Okay. Now let us work out this problem. Okay. Now I'm going to apply nodal analysis. Okay. And kindly understand this 3 ohm resistance is open circuit, it is null. Okay. You can simply ignore, you can simply remove from the picture by applying nodal analysis at V1. Current entering 4, okay, 5, sorry, is equal to V1 minus 4 by 2. Right? That's all. So the other resistor is also void because you have directly the value of voltage. So the 3 ohm resistor is also virtually no use. So please students, sometimes questions will be asked purposely to confuse you. Okay. So students, don't try to 4 by 3 and all. It is totally useless to write. You have to be too smart and too sharp. Okay. So GATE is not merely something like a descriptive paper. It will simply test your sharpness and skill. Okay. So these problems will be too sharp and you should be very cautious to understand. So you can notice that the 3 ohm which is connected in parallel with 4 volt is virtually of no use. Okay. So phi is equal to V1 minus 4 by 2. So 10 is equal to V1 minus 4, or V1 is 10 plus 4, 14 volts. Right. So V Thevenin is actually 14 volts. Are you able to understand? Okay, so please take care of such problems which will obviously test your skill. Okay, now let us work out a problem related to GATE 2002 EEE. Okay, this was conducted by Indian Institute of Science. An electrical network is fed by two AC sources as shown in the picture. Z1 1 minus J, Z2 1 plus J. The load impedance is 1 plus 0 j ohms. Obtain the Thevenin's equivalent circuit across the terminal XY and determine the load current through ZL. Okay, so you are supposed to obtain the Thevenin's equivalent circuit, Thevenin's voltage and impedance. Kindly understand one thing. If it is a DC, it is a resistance. If it is AC, it is impedance. Okay. You have two voltage sources, V1 and V2. V1 is 30 angle 45, V2 30 minus 45. Okay. Now let us approach the problem. So here the first step to determine VThevenin is remove the load impedance ZL. Okay. So virtually you have only one loop and only one current flows. So the first step is determine the total current. I is equal to V by Z. So I'm emphasizing Z not R because it is a AC network. For a AC network, a frequency comes into picture. So it is impedance R plus J X. For DC, frequency is 0. So it is only R. Now, I is equal to V by Z 30 minus 2 plus. So the sign, even though it is AC, we have to put the sign notation for the for the sake of understanding the potential network. Okay, so 30, 45 degree minus 30 of minus 45 divided by Z. What is Z? Z1 plus Z2, 1 minus J plus 1 plus J. So I is equal to 21.21J. Okay, so you have to convert in the calcs, you have to convert to complex mode, or in the virtual calculator in the system, you have to convert to complex mode and get the answer. Now, what is VThevenin? I have to apply KVL across SY. Okay, so 30, 45 minus I into 1 minus J is equal to VThevenin. Okay, so VThevenin is very simple. It is 30 angle 45 degree from the calculations. Step 2, I want a looking back impedance or Thevenin impedance. Okay, it is not a Thevenin resistance, it is Thevenin impedance. Kindly understand. So to find the Thevenin impedance, it's very simple. I have to deactivate the active sources. What are the active sources? Two voltage sources, 30, 45 and 30 minus 45. You just draw a straight line. Because if I want to deactivate the voltage sources, I have to draw a short circuit line. Okay, so once I deactivate, what happens? These two are connected virtually in parallel. Okay, so it is Z1 Z2 by Z1 plus Z2. So the calculation is too simple and Z Thevenin is 2 ohm. Okay, finally, I am drawing the Thevenin's equivalent circuit across the load impedance. What is the load impedance? 1 plus J0, right? So this is the resultant circuit. I is equal to V by Z. What is V? 30 angle 45 divided by Z is ZL plus Z Thevenin. Both are connected in series, don't forget. So sometimes students by mistake they'll write V Thevenin by ZL. That is not correct. It is IL is equal to V Thevenin divided by ZL plus Z Thevenin, right? Because both Z Thevenin and ZL are connected in series. So the load current is 10 angle 45 degrees. Are you able to understand? So here also kindly understand, even though this is an AC network, still we are utilizing the sign notation for the sake of understanding the current flow and the potential network. Okay. Okay. Thank you. So please now kindly understand once again, whenever AC network comes into picture, it is not resistance, but it is impedance. That every student should understand. Okay. So be careful in that aspect. Okay. Now let us take the next question. Calculate the current in 4 ohm resistor using superposition theorem. Okay. Now let us have a short discussion about superposition theorem. You should understand one thing. In circuit theory, there are two types of circuits. One is linear, another one is non-linear. Mostly the order, if the order of the circuit is 1, or if the order of the equation is 1, generally it is linear, and if the order of the equation is higher than 1, it is, or it may be non-linear. What is meant by linear or non-linear? One of the famous statements is a circuit is said to be linear if it obeys the principle of superposition. Okay, that's why superposition theorem is very, very important. In a simple statement, we can say linear input is equal to linear output. That is, V is proportional to I. This is an example of a superposition statement. As the voltage goes on increases, the current should also increase, provided resistance is constant. Okay. So what is superposition theorem for a network says? It says that for a linear, okay, it is only for linear, non-linear circuits will never obey superposition. You should take care in mind. For a linear bilateral network which is activated by 2 or more sources, current through any network or voltage across any network is equal to algebraic sum of current or algebraic sum of voltage across the network when each source acts independently. When one source is activated, the other source are deactivated. Okay. To deactivate a current source, it must be open circuit. To deactivate a voltage source, it must be short circuit. This is what the statement of superposition theorem. Okay. Now let us consider calculate the current in 4 ohm resistor using superposition theorem. Okay. Now you have two current source, right? Sorry, you have two sources. One is a voltage source, another one is a current source. By the principle of superposition, when I activate one source, I have to deactivate the other source. So let us activate the voltage source and find the current due to voltage source. To deactivate the current source, I have to remove the current source, that is open circuit. Okay. Now see, the circuit has been transformed as follows. 2 and 2 are connected in parallel. Series, sorry, 2 and 2 are connected in series, 2 plus 2, 4. 4 and 4 are connected in parallel, 2. So 3 plus 2, 5, the total current is 5 amps. Sorry, 10 by 5, 2. Okay, so once again, I'm saying the 2 ohm and 2 ohm resistor are connected in series. So 4. 4 and 4 are connected in parallel, 2. 3 and 2 are connected in series, 5. So the total current is 10 by 5, 2 amps. Okay, so by current division rule, 2 into opposite resistance. What is the opposite resistance? 4 divided by total, 4 plus 4. So 8 by 8, 1 amps. So this is the current due to voltage source of 10 volts. Next, I want to activate the current source and I have to remove the voltage source. So to remove the voltage source, I have to short circuit. Okay. So you can notice 10 volts has been short circuited. So 4 and 3 will be connected in parallel. Right. Now find the equivalent resistance. 3 and 4 are connected in parallel together in series with the 2 ohm. And once again, okay, let us proceed. So you will be having only two resistive networks, 3.714 and 2 ohms. Now the current entering is 1 ohm. Okay. So you are supposed to determine the current value. So the current value by current division rule, it is 0.35 amps. Okay. So current through 4 ohm resistor is 0.35 into 3 divided by 7. Okay. So because you once again you have to consider the network. You have to find the current through 2 ohm, which is nothing but 0.35. This current is once again split across 4 ohm and 3 ohm. So once again, you have to apply the current division rule. Are you able to understand? So 0.35 into opposite. What is the opposite resistance? 3 divided by what is the total resistance? 7. Okay. So 0.35 into 3 divided by 7. So 0.15. So the total current is sum of current due to voltage source plus sum of current due to current source. 1 plus 0.15, 1.15. Right? So you can understand what is the importance and what is the necessity of superposition theorem. Okay, from the superposition theorem, you can understand which source is contributing more energy or more current. You can understand the voltage source is contributing more current because the total current is 1.15. Among that, 1 amps is supported by the voltage source itself. 0.15 is supported by current source. Okay, so the current delivered by the voltage source is very high. Okay. Let us proceed to certain different type of problems. Okay. So this problem is very, very important because this problem involves dependent source. Okay. I told you that dependent source are 4 types: voltage dependent voltage source, current dependent voltage source, voltage dependent current source, current dependent current source. Okay. And another important point you need to understand is you should not deactivate a dependent source. This is very, very important rule, but there are certain journals which negate this idea, which go against the idea, and they say that we can equally deactivate a dependent source. But now this is not the point of research debate or discussion. Here, you consider this plain rule that dependent sources should never be deactivated or removed. Okay, only independent active source can be removed. Now let us take the circuit. Okay, step 1, you activate the voltage source first. So when I activate the voltage source first, the 3 amp current source has to be deactivated, that is open circuit, right? So you have only one loop. Okay, so minus to plus plus, plus to minus, minus 2ix, minus ix, minus 2ix. So 10 minus 5ix is 0. From that, ix is 2 amps. This is actually ix1. This is current due to voltage source 10 volts. Now, to find the response of current due to current source, I have to deactivate the voltage source. So you have to short circuit. So the circuit will be transformed as follows. It has only one principal node. You just applying nodal analysis at node 1. Okay. Don't confuse yourself with the mesh analysis because it will create a super mesh. Okay. Now I am going to apply the nodal equation or Kirchhoff's voltage law at node 1, right? So current entering is equal to current leaving. 3 is entering. So from the arrow mark, you can notice that it is plus 3. Plus 3 equal to V1 by 2 plus V1 minus 2Ix by 1. Okay. Now what is Ix minus V1 by 2? Why it is minus V1 by 2? You can notice that it is in opposition to V1. Okay, so it is minus V1 by 2. Okay, so Ix is nothing but minus V1 by 2. If you just substitute, you will be getting V1 is equal to 1.2. Since Ix is minus V1 by 2, minus 1.2 by 2 is minus 0.16. Okay, so this gives the final solution. The total current is current due to the voltage source plus current due to the current source. Okay, so it is 2 minus 0.6, it is actually 1.4 amps. So here also the source which is contributing to the maximum current is voltage source. Okay, so please take care of the direction. The direction is very, very sensitive. I have written Ix as minus V1 by 2. The reason is, you can notice it is actually opposing. Okay, it is actually opposing the node 1. Right? Okay. Now, let us consider an AC network here. The goal of this problem is to find the Thevenin's equivalent AB for the given circuit. Okay. So kindly understand, students, whenever AC network comes into picture, okay, impedance is the contributing parameter and not a resistance. Okay, so you can notice that you have few impedance here. We want Thevenin's equivalent across AB. And once again, I'm saying J5 minus J4 are virtually open circuited. It will not contribute for Thevenin's voltage. They will contribute only for Thevenin's impedance. Okay, so kindly understand and do not commit any errors there. Now we shall proceed with the problem. Okay, so here our process is still easy. I'm going to apply voltage division rule. Okay, so that is to find voltage across any network or any impedance, V into Z1 divided by Z1 plus Z2. That gives you V1. If I want to find a cross second impedance, V into Z2 divided by Z1 plus Z2. Okay, this is something like actually dual of a current division rule. Okay, so if I want V of AB, simply I can multiply 50 into 4 by 4 plus J6 divided by 4 plus J6 plus 3 minus J4. Okay, so 50 into 4 plus J6 divided by 4 plus J6 plus 3 minus J4, which is nothing but 200 plus J300 divided by 7 plus J2, which is nothing but 49.52 angle 40.36 volts. Okay, this is VAB. Okay, so this thing you can also use Kirchhoff's voltage law. That is, you can find the current first I is equal to V by Z. That is 50 divided by 7 plus J2. And after that, you can determine the drop across 4 plus J6. Okay, so that will be too complex. Instead of that, directly use the voltage division rule, which will obviously help you to get more, to help you to reduce time. Okay, you can just solve by 30 seconds hardly. Now, I want to find the Thevenin's equivalent impedance. Okay, so even though it is measured, it is mentioned as resistance, please understand you should take it as impedance. So for that, what should you do? You have to deactivate 50 volts. You just draw a straight line, short circuit. Okay, now 3 minus J4 and 4 plus J6 are connected in parallel. Okay, so convert that to series, and together they are connected in series with J5 minus J4. Okay, so here the open circuit comes into picture. Do not neglect the open circuit now. Okay, because it is actually a looking back resistance. Clear? Okay, so now the equivalent impedance is 4.83 minus J 0.094. You found out V Thevenin, that is 49.52 angle minus 40.36, and impedance 4.83 minus J 0.094. You just draw the voltage source in series with Thevenin's equivalent impedance. Okay, so this is the problem related to Thevenin's network for AC circuits. Okay, so whenever AC circuit comes into picture, you have to be too cautious. Even though the problem may seem to be simple, sometimes mathematical errors will affect our marks. Okay, you need to be pretty careful. Okay. Now let us consider a complex network, okay, which has two active sources, one current source and another one is voltage source, and most important, it is a AC network. Using superposition theorem, find the current through 4 ohm resistor. Okay, I told you already, the current through any network is algebraic sum of current when each source acts independently. So when one source is activated, the other source must be deactivated. Okay, now first let us activate 20 angle 90-degree voltage. So if I activate voltage source, the current source must be removed. It must be open circuit. Okay, now the goal is to find the current through 4 ohms. Let the current due to the voltage source may be I1. Now, first find the equivalent impedance. 8 plus J10 and minus J2 are connected in parallel, together in series with 4 minus J2. Okay, so the equivalent impedance is 4.25 minus J 4.25. Now, I1 is V divided by Z. Okay, what is V here? 20.90, and what is Z? 4.25 minus J 4.25. Okay, so I1 is 3.32 angle 135 degrees. Okay, so the angle is of second quadrant, take care in mind. That's why you're getting current as negative. Okay, first quadrant is always positive, the second quadrant is negative. So you can notice that in rectangular mode, the current is actually negative. Okay, the real term is actually negative because the angle is in second quadrant. Now, what is step 2? Step 2 is very simple. You have to activate the current source and you have to deactivate voltage source. I told you clearly, if you want to deactivate the voltage source, you have to short circuit. Nothing but you have to draw a straight line. Okay. Now, you can notice that you have 3 loops. Okay. So, best way is you can use a mesh analysis. Now, at the first mesh, you can notice I1 is equal to 5 amps because directly it is given. So, our step becomes pretty easy. Now, let us apply KVL for loop 213. And here we are using sign notation for the purpose of considering the direction of current. Okay, so at the loop 2 minus C, the tail of the arrow is always negative, the head of the arrow is positive, minus 2 plus, plus 2 minus, plus 2 minus. So minus 2 plus, plus 2 minus, plus 2 minus. Okay. Now let us apply KVL at loop 2, minus 2 plus minus J10 I1 minus I2 plus J2 I2 minus I3 minus 8 of I2. Okay. So see here, plus 2 minus. So I'm considering loop 2, minus 2 plus is plus. So plus J10 I1 minus I2. Why I1 minus I2? Because I1 is the principal current of node 1. We are taking node 1 as reference. Plus 2 minus. Minus of minus plus. Plus J2 I2 minus I3. Plus 2 minus minus 8 I2 equal to 0. Now let us consider loop 3. Minus 2 plus. So minus J2 I1 minus I3 minus 4 I3 plus. So minus J2 I2 minus I3 equal to 0, right? So after writing all these equations, the goal is we are supposed to find I3. Okay, so convert this to matrix form, that is the Cramer's rule. This is 2 cross 2 matrix. You have to find only del 3 by del. Don't waste your time unnecessarily by finding del 2. We want a current through that resistor 5 ohm. Okay, see the circuit clearly. We want the current through 4 ohm resistor, which is nothing but current I3. Okay, so I3 is del 3 by del. Okay. Now, what is current through 4 ohm resistor? It is actually I1 minus I3. Okay. So you can notice clearly here. So IL is 6.11, angle of 144.78 degree, or minus 5 plus J 3.512. Right? Kindly, another important thing, the question that is tricky here is how the current is I1 minus I3. Okay, so see here, the current due to the voltage source, it is taken from the reference of voltage, right? Now, in when I substituted or when I took the current source as active, I3 is just opposite to IL. Okay, so it is actually minus I3. So I of L is current due to voltage source plus minus of current due to current source. So it is I1 minus I3, right? So I have to subtract I1 minus I3, which is in polar form 6.11, angle of 144.78. And in rectangular form, it is minus 5 plus J 3.52. So you can notice that whenever the current shifts to second quadrant, the real term is always negative, but the imaginary term still remains positive. Okay, so you can easily understand the nature of shifting. the current through second quadrant. Okay. So kindly understand, students, working out the theorems is very, very essential, and you should know how to approach the problems. Okay. And even though it is AC, we are using sign notations only for sake of understanding, right? So whenever superposition theorem is involved, you have to activate only one source and you have to deactivate all the other sources. Activating if you deactivate the current source, you have to open circuit. If you deactivate the voltage source, simply you have to short circuit. Okay. So I hope we had a detailed discussion about the problems, and you should know how to approach the problems related to uh, theorems. Okay. And kindly understand one thing, the Norton's theorem is actually a dual of Thevenin's theorem. In Norton theorem, you are actually converting a complex circuit into a simple circuit, okay, with a short circuit current and voltage source. In Thevenin, you are actually converting a complex circuit into a simple circuit with a voltage source in series, okay, in series with an equivalent resistance known as Thevenin's equivalent, right? Okay. Now let us consider another problem. For the circuit, okay, okay. For the circuit shown in the figure, the Thevenin's voltage and resistance at XYR. So take care, you have one dependent source, current dependent voltage source, that is 2I, where I is the current through 1 ohm resistor. He has given 4 choices. Let us proceed. Okay. Now, you can notice that you have only one principal node. Okay, that is V1. I'm going to apply Kirchhoff's current law at node 1. What is current entering? 2 amps. Current leaving is V1 by 1 plus V1 by 2 plus V1 minus 2I by 1 equal to 2. But what is I? I is equal to V1 by 1. I'm just substituting that. So V1 minus 2 V1 by 1 plus V1 by 2 equal to 2. After simple manipulation, V1 is 4. V1 is nothing but voltage across XY. That is Thevenin's voltage. Okay. It consists of only one node. So dear students, even though the circuit seems to be a terrific, the approach is very simple. Okay. So here comes the practice. See, it consists of only one principal node. Don't attack the problem with a mesh analysis. It is too complex. Be smart. Only one node. It is not hard work. It is smart work here. Coming to the next step, I want a Thevenin. So here, what I'm doing, I'm virtually creating a short circuit. Okay. So when I create a short circuit, ISC, right? So ISC is nothing but what? 2 amps, right? So because of what happens when you create a short circuit, the entire current flows through the short circuit only. The other networks is obviously remains to be dead. So what is R Thevenin? V Thevenin divided by short circuit current. What is V Thevenin? 4 volts. What is short circuit current? 2 amps. Okay, so R Thevenin is 4 by 2, 2 ohms. So the result is V Thevenin is equal to 4 volts and R Thevenin is equal to 2 ohm. So see here, I'm creating a virtual short circuit like Norton's. Okay, across AB, I'm creating a short circuit. When I create a short circuit, the 2 ohms will be dead. Okay, 2 into 0 divided by 2 plus 0 is what? 0. Okay, understand one important point. Whenever you connect a short circuit across any resistor, okay, the resistor becomes dead. Okay, that is very important to understand. You are left only with one voltage. Okay, are you able to understand? So, which is 2i? Once again, here also 2i is actually dead only. Okay. So, R Thevenin is V Thevenin by ISC 4 by 2, 2 ohms. The result is V Thevenin is 4 volt, R Thevenin is 2 ohms. So, choice D is the correct answer. Okay. So, see here, such questions involves more practical understanding. Okay. You cannot blindly give some values like a 0 or 1. Okay. Approach to the problems are very, very important. Okay. So, thank you for attending the session. In the next session, let us focus more problems related to AC circuit analysis. Thank you very much.